We're asked to look at this differential equation and determine if there is a min or max or neither at the point given. See that f of 3 equals 6, so that means my x value is 3, and my y value is 6. I'm going to write that coordinate here just so I remember it. And we're given dy dx. And there are a couple things that we need in order to determine if we have a minimum, a maximum, or neither. And what we need to do is we need to test the first derivative and then the second derivative. We're going to use what we remember is the second derivative test. Second derivative test. And now what is the second derivative test? The second derivative test tells us that if the first derivative equals 0, then we can tell by the second derivative sign whether or not we have a maximum or minimum. And so let's test this out. First off, does this first derivative equal 0? Let's test it. Okay, so dy dx equals, and y I'm going to replace with 6 over 1 minus 3 plus x, which is 3. We're going to get 6 over 2 plus 3, 6 over negative 2, sorry. So negative 3 plus 3, yep, that equals 0. Okay, so this checks out, which means that we do have some extrema, and we need to figure out what type of extrema it is. We can test that using the second derivative. Now to find the second derivative, we need to actually find the second derivative of this differential equation we have here. Since we have dy dx, we're going to find the derivative of what's on the right. In order to find that, I know that y over 1 minus x, I'm going to have to use the quotient rule. So that's top times root to the bottom, or f g prime, f prime g minus f g prime, I believe, sorry. Derivative of f over g equals f prime g minus f g prime all over g squared. And so we're going to use that here. The derivative of the first thing, which is the numerator, y, is just dy dx. We're going to say d squared y over dx squared equals dy over dx times the next term, or times the denominator that we just keep the same, minus, and then now we keep this the same, and then we do the derivative of 1 minus x, which is just negative 1, all over that denominator squared, 1 minus x squared, plus the derivative of x, which is just 1. Alright, so what we can do is we can distribute things, make sure things look nice. So this will be dy over dx, 1 minus x, minus plus y, because it's times negative 1, all over 1 minus x squared plus 1. And you might be like, oh, what do I do with that dy dx? Well, we already know what dy dx is. It tells us in the question up here. dy dx is y over 1 minus x plus x. And so we can plug that in. Oops, sorry about that. We can plug that in. Y over 1 minus x plus x. 1 minus x minus, or plus y, all over 1 minus x squared. And then all of that plus 1. Now what do we do here? We have to plug in the point. We have to find d squared y over dx squared, which is the second derivative, at 3, 6. And so we're going to plug in those points that we know. And then let me use a different color. I'll use green to help us out here. So we're going to plug in those points. 6 over 1 minus 3 plus 3 times 1 minus 3 plus 6 over 1 minus 3 squared, all plus 1. 6 over 1 minus 3 we saw was negative 2. So 6 divided by negative 2 is negative 3. This whole thing, I'm going to highlight in a moment, this whole thing will equal 0. So that whole thing will equal 0, because 0 times anything is 0. So in the numerator, we're just left with 6 over 1 minus 3. That's negative 2 squared is 4 plus 1, which is 3 over 2 plus 2 over 2, which is 5 over 2. Now, really, the actual number doesn't matter. What matters here is that our derivative is positive. It's greater than 0. And so that means that we have a concave up function. As a reminder, I'll draw this here. If we have a concave up, that means we're looking at a relative minimum. And so our final answer that I will write in blue is that we have a relative minimum at x equals 3, or not x equals 3, sorry, at 3 comma 6 is how we should write it, because dy dx at 3 comma 6 equals 0, and the second derivative at 3 comma 6 is greater than 0. And there's our final answer.